All right, so today's lesson is on radian measure 8.8. And the first two problems tell us to sketch an angle with an indicated angle measure without using a protractor. So the first thing you want to do is think about, okay, well, what degrees am I familiar with? I'm familiar with 180, which is a line. And then halfway through, perpendicular, would be a 90-degree angle, which is 90 degrees. So where is 150 in relation to that? It's going to be about somewhere between 180 degrees and 90 degrees, so somewhere around here. And this is just an estimation, just to familiarize yourself with degrees. So this arc length right here would be about 150 degrees. All right, now if we look at 30 degrees, let's think about degrees that we're familiar with. So we're familiar with 90 degrees. And what would 30 be? 30 would be a third of that. So it'd be about here is my 30-degree angle. All right, and angles can be measured in degrees and they can also be measured in things called radians. So a radian is similar to degrees in that it measures around a circle. So for example, a first full circle is going to be 2 pi. That means half of a circle, 180 degrees, is the same thing as pi. So keep that in mind because you're going to use this to help you transition from degrees to radians. Now, you're not super familiar with radians, but you'll be using them a lot next year. So you have to make sure you familiarize yourself with them, okay? All right, so we've got our equation right here. The radian measure is the arc length divided by the radius. So you can just write that down somewhere. And it's giving us this right here is the arc length. That would mean arc length like this. It's just a portion of the circle. And then this is our radius. So what we're going to do is we're going to do 3 pi over 8 divided by 3. And then remember with fractions, you're going to take 3 pi over 8 times 1/3, which is 3 pi. Sorry, these cancel out, which is pi over 8. Now, what does that mean? So if I'm thinking about degrees, I can change that by multiplying times 180 over pi. Because remember I said that a full circle is 2 pi. Half a circle is pi, and which is 180 degrees. So those are the same things. So you're essentially just multiplying that by 1. And so if you want to know how many degrees that is, these cancel out. And then 180 divided by 8 is 22.5 degrees. I'm just going to leave that off the side. I'm just showing you how to convert from radians to degrees because you'll do that a lot. All right, the next problem is telling us to do 25 pi. So 25 pi is our arc length. And then R stands for radius. And we're going to take 25 pi divided by 10, which is 25 pi over 10. And then if you reduce that by 5, you're going to get 5 pi over 2. And if I want to see how many degrees that would be, I multiply that by 180 over pi. Pi's cancel out. And that's 450 degrees, which means it goes around the circle once and then a little bit more after that. All right, this next section saying it's explaining a bit more what a radian is. So a radian is a unit of an angle. It's equal to an angle at the center of a circle whose arc is equal in length to the radius. How many radians fit in a full circle? How many radians fit in a semicircle? And I already went over this, but this way you have it written down somewhere. So a full circle is 2 pi. You take your arc length, you divide it by the radius, and that's how you're going to get it. So, your arc length for a full circle is your circumference, so 2 pi r, and then divided by your radius, that's how you get 2 pi, which is 360 degrees. So those are exactly equal to each other. And then if you're looking at a semicircle, remember that goes through the diameter. I mean, obviously, if you know a full circle is 2 pi, then that's going to be pi. So when you're talking about radians, it's pi. And that's 180 degrees. And if you notice right here on this left circle over here, that's explaining the definition in a diagram. So it says a unit of an angle equal to an angle at the center of a circle whose arc is equal in length to the radius. So that means that from here to here, that's my arc length, that's my radius. That's the same exact distance as from here to here. And that's why it's 1 radian. But I think when you convert your radians to degrees, you can understand better what that means in terms of the full circle. So the first part, we're going to take our degrees and turn them into radians so you can see what that looks like. So 60 degrees, what you do is you multiply times pi over 180, and you're really just multiplying by 1 because they're the same thing. Pi is 180 degrees. So we have 60 pi over 180. The zeros cancel out, and then you get 6 over 18, which you can reduce by 6, and that becomes pi over 3. So 60 degrees, if you turn that into radians, that's pi over 3. 720, like if we think about it, 360 is 2 pi, then obviously it's going to be bigger than 2 pi. So let's go ahead and multiply that so we can know exactly what it's going to be. So times pi over 180, and that's going to be 720 pi over 180. And if you use a calculator, you're going to get 4 pi. Or you can also think about it. 360 is 2 pi. 360 times 2 is 720. And so that's why it's 4 pi. All right, and now we're going to go backwards. You have radians, and you can convert that to degrees, and you just are going to flip it. Make sure that however you have it, you're able to cancel out a term. So for example, over here, when we were converting from degrees to radians, you see how you have a number on the top and then you have a number on the bottom. So those are going to simplify. Over here, you want to be able to cancel out your pi's. So 3 times 180 is 540. And then over 4 is 135 degrees. So that's the same thing as 3 pi over 4. Next year, in math 3, you're going to use radians a lot, so you have to become very familiar with them. They are the same thing as degrees, but they just look a little different. So for this one, again, we would make sure that the pi's cancel out. So you want to make sure that the pi's in the bottom the denominator. You can reduce before you multiply. So for example, I have 3 and 180. I know that I can reduce that to 60 because they're both multiples of 3. And then 6 times 25 is 1500 degrees. So that goes around quite a few times in a circle. And now if we're going to sketch these, it says sketch an angle with the indicated angle measure. Your angle should be approximately the correct size. Do not use a protractor. So we're given radians and they're asking us to sketch them just like we did at the top. Now, if I look at the radians, it really doesn't mean much to me. But if I convert it to degrees, then I'll be able to estimate where that would be in a protractor, where that would be in a circle. So these are going to reduce. That's going to be 18. So it's 18 over 10 simplifies. And so 7 times 18 is 126 degrees. So what does that mean? That means this is full line is 180. This is 90 degrees. So 126 degrees would probably be a little closer to the 90 degrees than the 180. So it'd be like about here. All right, we're going to do the same thing with the second one. So times 180 over pi. These are going to cancel out. 9 goes into 18 two times. So that's going to be 20. And we end up with 40 degrees. So if we have 90 degree line right there, this is 90 degrees right here. So 45 would be exactly halfway. So 40 would be just a little bit lower than that. That's 40 degrees.